let's start with the today's theory. So I hope you know DFS. DFS is a technique of graph traversal in which you use a stack and just push the element, and whenever it's like traversal complete, you can't go anywhere, you just pop out. Okay, like for example in this graph, you can maintain an adjacency list. Like this is a vector, and every node of this vector contains a vector. Okay, you can also make a map, and every key contains a vector or list of list or anything you can think of. Okay, so 1 is connected to 2, so 2 is posted in one stack. 2 is connected to 3 in a directed edge, so in 2 we have pushed 3. So like this we have pushed everything. Okay, so let's start DFS. This is a call stack. You are starting with this node, so let's start with 1. Then 1 can go to 2. Okay, 2 can go to 3. 3 can go to 4. 4 can go to 5. 5 you can go to 7. Okay, now 7 you can't go to anywhere because 7 is connected to no edge. So let's pop this out. 7. Okay, when the DFS completes and you are popping out, just store it somewhere. Okay, I will tell you why. Then reverts back to 5. Okay, 5 is also not connected to anywhere. Now as 4 is already visited, 7 is already visited. Okay, sorry, 5 is going to 7, so 7 is already visited. Okay, so call stack completes. 4 also, then 3 also, but 3 you can also go to 6. So let's push 6. 6 you can't go to anywhere, so pop it out and then pop 3. Okay, then then you will go to 2. 2 also you can't go anywhere, so pop 2 and then pop 1. Okay, in this way it is also known as topological sort. Topological sort means, sorry topological sort means you need to complete 7 first. Then you can complete 5, then 4, then 6, then 3, then 2, then 1, in order to achieve like no cycle. If you want to do 7 work first before 5, like that. Okay, so let's see this question. In this question you are starting DFS by this. Okay, then you went to this node. Okay, let's take some different. You started DFS with this and you went to this node. Okay, you mark and then this node you can't go anywhere. Okay, so you mark visited as 2. Okay, you gone back. Now here you can go here you can go here. Visited 1 only, 1 visited 1. Then you can see that you can go here. Okay, but if you will not mark it visited as 2, then you will go here and you will see it is a cycle, but it is actually not a cycle in that graph because it is not in your stack. You already completed DFS. Now you are encountering this current cycle. Okay, so you said that is visited as 2, so we are all okay, we should not consider this. So we go to here, his visited is 1, yani it is in the present call stack. It means this is a cycle. Okay, so you got it. Like whenever you are outside the stack, just mark it as visited 2, like it is not in the current stack. Now you can see another cycle. Okay, so let's get started. Okay, so this line you read carefully. It is saying that you must take course B1 first. If you want to take course AI, like B1 you need to go take first, like second element you need to do if you want to do first. It means like two elements AI BI, and you need to do BI first if you want to do AI. If you want to do AI, you need to do BI first. Okay, so there is an edge between BI to AI. Okay, so you need to push the element like V1 dot pushback V2. It's in the agency list. Okay, so that you take care, and let's get started. So I think I should not waste much time. I can write also, but let's write number of courses and D. You need to make a agency matrix. Okay, you can declare globally so that you should not pass in the DFS and all. So let's declare globally vector of agency array, like each indexes represent array. Number of nodes is like 2000, so you can make like 2005 or something, 2001. Make a visited array, like which node is visited and all. Okay, then make a, like you will get a vector out of A, right? So you can also write auto data type, auto, and H is your get 9. Okay, and the agency matrix we are pushing. I told you BIs before, so just like this. Okay, now your graph is ready. Now you will iterate to all the nodes. Okay. 2 means 2 means there are like 2 nodes starting from 0 1. Okay, now if the nodes is not visited, then you just need to call the DFS. Okay, DFS will return it has cycle or not, and if it has cycle, it means we can't schedule the course. Okay, so if DFS return true, means it has a cycle, then means it has a cycle. Okay, so we should return false, that we can't do this. Okay, so please read out the question. It is easy only, that for doing the course 0 you need to complete first course, and in this way can you complete all the courses or not. Okay, so if it has cycle, like you want to do course 5 suppose, and you need to complete it 4 course first, but for 4 you need to complete 6, and for 5 you need to complete like for 6 you need to complete 5, so it is a cycle. Okay, so okay, let's get, so this will return it has a cycle or not. So supposing contain node, make it visited. Okay, okay, don't think it is already visited, because we will call the DFS if it is not visited. Okay, then let's take a bool flag in which it is like cycle not found. Okay, then go to every child. Okay, again go to every child in the agency list it is stored. So go to every child and see if the visited of C is equal to 1. Like this node is already, like, let's explain one thing. If you are here, okay, and you see that it's visited is like you are going, okay, going, okay, and you are going, and you have seen that you have started from here, visited 1, you are in the college tech, and you again come here whose visited is 1. It means you have found a cycle, simple. Okay, and it is also not in the college, it is also present in the college tech. Okay, if its visited is 2, since it is not in the stack, so it is not in the current cycle, so you can ignore it. So if it is 1, means cycle found, because it is in the current college stack, you can say. Okay, so we return true. Okay, else if what visited of C is if equal to 2, means we have already completed it in this node DFS. Okay, we just need to continue, do nothing else. If visited of C if not equal to 1, sorry, equal to 1 you have considered. If it is not visited, then you will call it ifs. Okay, sorry. If it is not equal to 2, and if it is not visited, you will just call that ifs. Else it is not visited, so you will just call the DFS. Found or equal to means if by any means this now this node traversal returns that it has a cycle, it means this node also has a cycle. Okay, so like we'll do this. Okay, and at last we have completed our call stack. It means we will mark that node to 2. Okay, and then we will return found. Okay, so let's run it. Okay, thanks. I hope you got the solution. It's easy only. Whenever you finish the DFS, just mark that node visited array to 2, like its call stack is completed. Now if you encounter any visited node, visited equal to 1, it means you found a cycle. Okay, and if you have not visited, then just carry on. If any of the node returns true, it means you also has a cycle. Thank you. I was ill yesterday, so I have not like bring up yesterday's video, but actually I'm not practicing graph much, so maybe this is the reason that I was not I have two solution. I was not confident enough on the second solution. I was thinking to explain every approach, so I haven't made the video. But once I will be practicing so much graph question like continuously, then I will be like making video yesterday also. And thank you. Hope it's not a graph week. Okay, thank you.